Prefix used in a unit of a physical quantity. Prefix, power of 10 and symbol. Exa, 10 to the power 18, symbol is capital E. Prefix peta, power is 10 to the power 15, symbol is capital P. Tera, 10 to the power 12, symbol is capital T. Giga, prefix giga, power 10 to the power 9, symbol capital G. Prefix mega, power 10 to the power 6, symbol capital M. Kilo, prefix kilo, power 10 to the power 3, symbol K. Hecto, power 10 to the power 2, symbol small h. Deca, 10 to the power 1, Da. Deci, 10 to the power minus 1, D. Centi, 10 to the power minus 2, C, small c. Milli, 10 to the power minus 3, small m. Micro, 10 to the power minus 6, mu. Nano, 10 to the power minus 9, small n. Pico, 10 to the power minus 12, small p. Femto, 10 to the power minus 15, f. Atto, 10 to the power minus 18, a. For example, if we are written 1 kilometer, here we see 1 kilometer. We have physical unit is meter, and before it we use 1 kilo. Then meter will be multiplied by 10 to the power 3. So our answer will be 10 to the power 3 meter. Similarly, 1 millimeter, here milli is prefix which is used before meter. So meter will be multiplied by 10 to the power minus 3. Here 10 to the power minus 3 meter. So 1 millimeter will be equal to 10 to the power minus 3 meter. Similarly, 1 nanometer. Now the value of nano is 10 to the power 9. So 1 nanometer will be equal to 10 to the power minus 9 meter. Again, 1 kilowatt. The kilo represent 10 to the power 3. So 10 to the power 3 watt equals to 10 to the power 3 watt. Again, 1 picofarad. Farad is the unit of capacitance, but we have used prefix p, pico, and pico is equivalent to 10 to the power minus 12. So we have 1 picofarad equals to 10 to the power minus 12 farad. Some practical unit. There are some practical units which are simultaneously used with SI unit. For example, astronomical unit, which is represented as AU. The average distance between Earth and the Sun is called astronomical unit. 1 AU equals to 1.496 into 10 to the power 11 meter, equivalent to 1.5 into 10 to the power 11 meter. This distance is the average distance between Sun and Earth, and this is called astronomical unit. Again, we have 1 light year. This is the distance traveled by the light in vacuum in 1 year, is called light year. So 1 light year will be equal to a speed of light in vacuum into 1 year. That is 3 into 10 to the power minus 8 meter per second into 365 into 24 into 60 into 60 second. So finally we get 9.46 into 10 to the power 15 meter. So 1 light year will be 9.46 into 10 to the power 15 meter distance. Again, third one is parsec or parallactic second. It is the distance at which an arc of length equal to 1 astronomical unit subtends an angle of 1 second. This is shown in the figure. Here distance between these 2 points is 1 astronomical unit, and if this arc subtends at any point here, for example at this point, of an angle of 1 second, then the distance of this point from this line will be equivalent to 1 parsec. Now we know that theta equals to arc by radius. This implies we have a radius equals to arc by theta. Hence we can write 1 parsec equals to 1 astronomical unit by 1 second. Now we can use the value of second like this. We have 1 minute equals to 60 seconds, so 1 second will be equals to 1 by 60 minutes. Again 1 degree is equals to 60 minutes, so 1 minute will be equal to 1 by 60 degree. So 1 second will be equal to 1 by 60 into 1 by 60 degree, 1 by 3600 degree. Again we have pi radian equal to 180 degree, so 1 degree equals to pi by 80 radian. So we will convert this into radian. So 1 by 60 into 1 by 60 degree will be equal to pi by 180 to 1 by 3600 radian. So we have put this value here, and astronomical unit is here, and solving this we finally get 1 parsec equals to 3.084 into 10 to the power 16 meter, or 3.1 into 10 to the power 16 meter. The distance between stars usually expressed in parsec. So 1 parsec is equivalent to 3.26 light year. Some another units are, for example, 1 Fermi, which is equal to the 10 to the power minus 15 meter. These are practical units that are used regularly. For example, 1 angstrom, which symbol is angstrom, and its value is 10 to the power minus 10 meter. Similarly, 1 nanometer, whose value is 10 to the power minus 9 meter. 1 micron or micrometer, 10 to the power minus 6 meter. 1 light year, 9.46 into 10 to the power 15 meter. 1 mu atomic mass unit, 1.66 into 10 to the power minus 27 kg. 1 quintal equals to 100 kg. 1 ton equals to 1000 kg. 1 lunar month equal to 27.3 days. 1 solar day, 366.25 sidereal days. 1 sec, 10 to the power minus 8 second. Now order of magnitude. The order of magnitude of a physical quantity is that power of 10 which is closest to its magnitude. It gives an idea about how big and how small a given physical quantity is. A number can be expressed as n equals to n into 10 to the power x. If 0.5 is less than n, is less than equal to 5, then x will be order of magnitude of the number. For example, here C, we have 0.4 into 10 to the power 6. Now here 0.4 equals to n, which is here n less than 0.5, that is does not lie in the limit. So we can write n equals to 0.4 into 10 to the power 6 equals to 4 by 10 into 10 to the power 6 equals to 4 into 10 to the power 5. Now n equals to 4, and this n value lies between these limits 0.5 to 5. So order of magnitude now, and here the power is 5, so the order of magnitude has become 5. You can see in the above example we have given n equals to this number. Now this can be written as 4.571 into 10 to the power 7 meter. Now this number is lie within this limit 0.5 to 5, so this can be used as it given. So the order will be 10 to the power 7, that is 7. Hence order of magnitude 7. So by the approximation, this means that this number by approximation, if we let me say that if we want to express this number in the terms of order, then this number can be directly written as n equals to 10 to the power 7 meter. That is, we mean that any number can be expressed as a power of 10, and that is the order of that number, that measurement or value or number. For example, here again one number is given, n is equal to 0.5 into 10 to the power 6. If we take this value as n, now since n should be greater than 0.5, but here it is equal to 0.5, so n will be, so we have to change it and make it greater than 0.5. So we have used this form, we have converted this number into this 5 by 10 into 10 to the power 6. Now this value is, this becomes 5 into 10 to the power 5. Now if we take this as a n, then it lies between the given limit, that is n less than equal to 5. Hence order of magnitude, that is order of that number or that measurement, will be 5. Now measurement of a length, direct method, from 10 to the power minus 5 to 10 to the power 2 meter. Measurement of length. The moderate lengths can be measured directly with the help of instruments like a meter rod, a vernier calipers, a screw gauge, or a spirometer. The minimum distance or length measured by this instrument is known as the least count of the device. What is the least count of a if you were asked what is the least count of a device, then you can say the minimum measurement taken by a device, measuring device, is called least count of that device. For example, the least count of a meter rod is 1 millimeter, or 10 to the power minus 1 cm, or 10 to the power minus 3 meter. So a meter rod can measure a length up to the accuracy of 10 to the power minus 3 meter. Or you can ask it 1 millimeter, or you can also ask it as 1 by 1000 part of a meter. That is, you make meter, you divide meter into 100,000 equal parts, and one part's measurement will be equal to 1 millimeter, and that can be measured by a meter rod accurately. Second, the least count of a vernier caliper is 0.01 cm, or 10 to the power minus 2 cm, or 10 to the power minus 4 meter. So a vernier calipers can measure a length up to the accuracy of 10 to the power minus 4, or 1 by 10,000 part of a meter. Again, third, the least count of a screw gauge or a spirometer is 0.001 centimeter, or 10 to the power minus 3 centimeter, or 10 to the power minus 5 meter. Therefore, a screw gauge or a spirometer can measure a length up to 10 to the power minus 5 meter or 1 by 1 lakh part of a meter. Now some indirect method used in length measurement. First is triangular method. Use height of a tower, pole, etc. can be measured with this method. For example, measurement of the height of a tower. Accessible objects. Here AB is the height of a tower, and we know we have to find first angle of elevation, and that can be find with the help of range finder or sextant. The angle of elevation at point C, point of observation. Here you consider this is a tower. A, B is a tower. Now you are here at this point C and you have to measure this height as. So you have to use sextant, a device that can calculate this angle. That is the base, the angle with this line with the base. And now if you calculate this angle, and because this distance you know this distance, so you can calculate h using the formula tan alpha equals to h by Ca equals to h by L. So h can be calculated as L into tan alpha. Why we are using this method? Because we are not knowing the height of tower, but you can reach here at its base and measure, and you can directly go at any point from this base and use your sextant device to calculate angle. And if you calculate angle, then you know this angle, and this you are knowing this length, and from help of angle and this length you are getting the value of height, that is the height of tower from this formula h equals to L tan alpha. Measurement of the height of an inaccessible tower. Same method can be used? No, this is a different method. An object whose distance from the point of observation cannot be measured. Oh, here you are not measuring the distance. You are not able to measure the distance of point of observation and the base of the tower or building. Observation cannot be measured directly is called inaccessible object. Example, a tree or a building on the other side of a river or a mountain, etc. This is the situation where you cannot directly go to the base of the tower. So this method can be used. This is the same method. Here what we do, consider it is a tower which we have to measure, but you cannot reach at this point, but you are at point C and you are at point D. This distance you know. So first we take the angle measurement from point C using sextant, and then again after moving some distance like D, you take the another angle by the sextant device, and that comes out to be beta. Now using the property of triangle, the height h can be calculated. Here are given the method. From triangle ACB we have cot alpha equal to Ca by AB equals to L by H. Again from triangle ABD, cot beta equals to AD by AB equals to L plus D by H or L by H plus D by H. So we can write cot beta minus cot alpha equals to L by H plus D by H minus L by H equals to D by H. Now you know the value of beta and alpha, so you can calculate the value of cot beta and cot alpha, and from this formula you can find the value of H, because you know the value of D. So this method can be used where you cannot access directly to the base of a tower or a building. This is the final formula for measuring the height. H equals to D by cot beta minus cot alpha. Now measurement of the diameter of the moon. This is a approx method to measure the diameter of a moon. For example, you are at this point and using some device you are able to measure this angle